Jailbreaking a frontier model isn't about throwing random prompts at it, it's about mapping the entire exploitation architecture before the first line of code is ever targeted. To systematically deconstruct the vulnerabilities of a frontier AI system, safety teams rely on structured, risk-centric methodologies rather than erratic prompt injection attempts.
Threat modeling and this risk-centric threat modeling process that me and actually another OWASP member from London, Marco Morana, we invented this methodology called PASTA. He's a native Italian, and we came up with this acronym to basically signify process for attack simulation and threat analysis. So I wrote this book with Marco Morana about last year, and through Wiley Life Sciences here in New York. And
utilizing a rigorous framework like PASTA enables evaluators to transition from chasing theoretical vulnerabilities to actively anticipating tactical, real-world exploits. Building an optimized attack tree requires engineering the structural branches from the bottom up to isolate systemic failure modes efficiently.
Bottom branches on your Huffman tree. Write them down with how often they're used next to them. That's called their frequency. Then connect them together, one level up, with the sum of their frequencies. Now, add that new sum back into your list, wherever it sits higher up. And repeat. Take the bottom two off your list, connect them up, add the result back in your list. Keep that going.
By treating adversarial paths similarly to data compression streams, we prioritize the highest probability vectors to shut down multi-modem exploits instantly. Evaluators must look past basic chat windows to analyze the underlying operational environments and service containers supporting the AI model.
We talk about attack trees or attack modeling for containers as a service. I wanted to just really emphasize that this talk is really more, it's kind of like a psychological attack-centric talk. So as security practitioners, you might be concerned about, well, what attacks exist, what countermeasures can I put in? But really this is all about trying to be criminalistic against containers, different types of containers that are out there.
Mapping these isolated vignettes allows red teamers to witness exactly how an autonomous agent can be weaponized inside its hosting infrastructure. Hardening frontier models begins at inception, embedding automated architectural boundaries before training data is even curated.
Microsoft has this fantastic tool called threat modeling. The purpose of the threat modeling tool is to help you design solutions and identify known vulnerabilities that could arise using best practices and known vulnerabilities in the marketplace. We're going to have a quick look at the threat modeling tool, start to design a two-tier architecture of a web app and a SQL database, and then see what recommendation the tool puts forward to help us secure our architecture and solution.
Shifting safety constraints left in the lifecycle guarantees that alignment anomalies are detected and fixed during early development. Modern AI safety transcends basic penetration testing, demanding systematic deep dives into how structural representations flow across untrusted interfaces.
Definition, and it took us like weeks and weeks of discussions and tweaks to get 15 people to agree on the definition, is analyzing representations of a system to highlight concerns about security and privacy characteristics. In other words, basically threat modeling means you start thinking about security and privacy early on and start thinking about all the things that can go wrong in your system so you can fix it before it actually happens.
Moving toward proactive threat modeling ensures security is an integral component of system design rather than a superficial patch. If the geometric baseline of your alignment parameters is warped, the entire safety infrastructure built above it will inevitably collapse.
I've got to build this foundation. And I'm not going to do a regular foundation. I'm going to use these 4x4s and I'm going to stack them and overlap them. Oh, and by the way, right off the bat, I'm cheating because I'm not considering this foundation build as part of our one-day time limit. You can see how these boards are warped.
Maintaining mathematical precision and pristine tracking metrics acts as the definitive framework that stops model evaluations from degrading into noise. Inside the intricate neural pathways of frontier architectures, specific logical layers are vulnerable to high-pressure exploitation that compromises internal weights.
Every tree you've ever seen is dead. It turns out the alive part of a tree is just a tiny paper-thin strip of cells trapped between a dead skeleton and dead outsides. Trees are some of the most extreme beings on Earth, with one of the most unique strategies in nature. On top of being mostly dead stuff, they forge their body out of thin air, They mercilessly crush rocks with acid, and they have an internal negative pressure that would kill.
Deciphering the foundational mechanics of these logical pathways, let's read teamers identify where query load creates systemic structural failure. Safety evaluations are entering an automated phase, leveraging advanced algorithmic red teaming to trace hidden adversarial paths humans overlook.
Threat modeling, and we're going to also talk about how we can perform threat modeling for cloud infrastructures using Terraform. And also, we'll be able to discover today how the rich data that is contained in Terraform code can be used as input for threat models. And we're also going to see some demos on security analysis of Terraform code.
Feeding threat intelligence pipelines rich operational data unlocks automated discovery of complex, multi-stage exploit chains. When an alignment filter fails under adversarial pressure, we measure the rate of degradation to calculate the structural limit of the security perimeter.
You look at the size of the timber that we have here, it is called massive timber. It's huge blocks of timber. And then there's a whole thing on charring.
Yeah, so the charring effect is essentially, as you know, when you burn timber, it chars. And so this timber, which is actually comes out of Austria, it's Austrian spruce, and the charring rate is very well researched.
Quantifying the resistance threshold under sustained adversarial interaction shows exactly how long the model preserves its alignment bounds. Forward-thinking red team operations require forecasting system behaviors and deployment environments multiple generations ahead, not just reacting to current iterations.
Think about the tree and actually how it's going to look, not just now, not just when you buy it from the nursery or from the garden centre, but how that tree is going to look, as you say, in 5-10 years' time, how it's going to look across the seasons, what is it going to add into your space. But I think from a small garden point of view, where space is at such a premium, it's the eventual size that I would say is the ultimate consideration.
The ultimate consideration for AI safety design is mitigating long-term resource dependencies and structural compute overhead. Pioneering safety evaluators initially had to engineer custom defensive architectures, using heavily constrained tools in untrusted environments.
Hey guys, I'm here with the West Arm Lodge. They're dropping me off deep in the heart of Canadian bear territory. There's black bears literally all over the place. I've got limited tools and I've got limited food. After that, I got to survive with whatever I can find in the woods here. I'm going to build myself a cabin from scratch using this materials. I got a couple windows. Oh, nothing like 100-year-old windows.
Surviving unpredictable digital ecosystems demands modular architecture capable of resisting highly creative, persistent threat vectors. The discipline expands rapidly by absorbing peer-reviewed insights from multidisciplinary safety teams pushing the envelope of alignment science.
Being surrounded by such bright people who are always wanting to change and changing because we always want to strive for better. So it's been really good for me being here. I know I sound like I drank the company Kool-Aid. I probably did. But you know, in orientation, I was told to bloom where I'm planted, and I have had the opportunity to bloom over in that adult ED.
Forging bulletproof AI defenses requires continuous collaborative evaluation and an unyielding commitment to raising security baselines. Constructing an actionable attack tree hinges on documenting the step-by-step linear progressions that transition an application from normal state to total breach.
A lot of there's all these different activities that go along with application threat modeling, like data flow diagramming, like maybe building an attack tree, or exemplifying a kill chain diagram for how an application gets compromised. A sequential, linear set of events that actually attacks a given application component. And so it's very architectural driven, it's very software driven, and that's good, but there's some...
This sequential focus exposes subtle transition points where benign user input becomes a multi-tiered system exploit. Each conditional node within an adversarial tree functions as a critical logic split, mapping exactly how an attacker navigates system weaknesses.
Right at the top, you now have a Huffman tree, and it looks like this. And it tells you how to convert your text into ones and zeros. Our first letter is the first uppercase W in WikiWiki Wild Wild West. Uppercase W is here, there's 141 of them, so go to the top, follow the path down. Each time you take the left-hand side, write a 0. Each time you take the right-hand side, write a 1. So W is this, only 5 bits instead of 8. Next lowercase I, follow the code down only.
Evaluating these logic paths down to binary states enables teams to accurately compute the computational cost and success probability of a breach. High-impact red teaming must always be anchored by targeted risk mitigation, targeting the actual exploit-ready vectors visible in production today.
Applications, this is going to be more driven from the perspective of true risk mitigation based upon viable threats and attacks that exist today and intents around compromising containers. So we have a quick brief outline.
Discovering gaps is only half the battle. The true metric of success is orchestrating a resilient, defense-in-depth perimeter around the model core. Tracing dynamic user workflows visually highlights precisely where data flows intersect with untrusted boundaries and where interception risks lie.
Now, as you can see in this web app, the workflow that I've created, that the user interacts with the web application from the browser, the request flows into the web application, a request is then raised to the SQL database then sends the response, and then the response goes back to the browser. That's what the workflow looks like. Now,
Extracting telemetry reports directly from these workflows allows engineering teams to patch critical vulnerabilities prior to market deployment. Proactive threat modeling means asking systemic, uncomfortable security questions early enough to completely alter the deployment trajectory.
Bringing it in early in the development lifecycle.
Love it. And then, since it's a threat modeling manifesto, is there a particular philosophy on threat modeling?
Well, so threat modeling you have different approaches, you have different techniques you can apply. But so the essence really boils down to the 4 questions that I mentioned before.
Adopting a strict security by design mentality is the non-negotiable prerequisite for protecting frontier architectures at globally distributed scales. Validating an AI safety framework requires establishing unyielding testing constants to guarantee every structural baseline is flawlessly balanced.
For most people, you're going to want to lay this out with strings so that you have everything square and just where you want it. But I have the advantage of already having my garden here, so I can just measure off of that to make sure it's exactly where I want it. Because I like doing things the easy way, I just lifted this one corner up to make sure that everything was level. Then I went around the whole thing with the shovel because it was just so slightly out that I was able to take a small amount out from underneath the entire perimeter.
Minuscule errors in foundational logic amplify exponentially, creating blind spots that mask the model's ultimate breakdown point. To neutralize modern automated attacks, an AI model's internal parameters require the algorithmic equivalent of industrial steel reinforcement.
Plants the strength to grow taller and claim the sun for themselves. But of course, now they were competing with each other, which must have been really annoying for them. So, as more millions of years passed, some plants just went all in on lignin and produced more and more of it, becoming stiffer, harder, and stronger. Until one day, around 385 million years ago, they got the biological equivalent to steel-reinforced concrete, wood.
Hardening these internal logic boundaries enables safety platforms to claim a sustainable defensive advantage over highly sophisticated adversaries. Modern red team analytics categorize real threats by balancing 3 core attributes: adversarial intent, technical capability, and environmental opportunity.
Threat defense, and we're also going to talk about, at high level how a threat model looks like. And oh, by the way, if you can notice the killer sea turtle, they are the top threats for the jellyfish, and so the jellyfish can self-heal if the turtles are attacking them.
Unmasking the precise capability profiles behind emerging exploits allows us to design attack trees that reflect actual production hazards. The goal is to isolate and neutralize anomalous training inputs before they interact with the network's processing layers.
So when they're growing, they suck in the carbon dioxide, right? That's how they grow. When they get to a certain age that they don't grow much anymore, they don't really suck in as much carbon dioxide. So by actually chopping them down and using them as a product, as a building product, we're actually trapping that carbon, we're storing that carbon dioxide in the timber itself.
Prioritizing streamlined, lightweight defensive layers ensures robust validation bounds without draining core runtime performance. Evaluators must recognize that a localized framework engineered today will eventually police sprawling, highly integrated ecosystem models tomorrow.
Interesting point, actually, because I don't think in some instances we should be put off necessarily by having big trees. It's whether that big tree is right for the space, and there may be some gardens where actually planting something like an oak would be one extreme, and obviously one of the most majestic big trees that you can possibly plant, or a beech, could actually be right. If you've got a garden that you want to add something that's a real statement, as long as you're aware, I think is the main point, as long as you're making that informed decision that this.
Making hyper-informed design decisions today prevents total operational paralysis when next-generation systems reach global velocity. In raw production environments, a single overlooked logic flaw is all it takes for an unauthorized exploit to breach system parameters.
Guys, picture this. Miles of untamed forest. The challenge, turn a pile of these trees into a bear-proof cabin. There's no hardware store, no backup plan, just me and the wilderness duking it out. In Black Bear Country, the stakes are high. One gap in the wall, one weak joint, and I'm hosting an uninvited guest with claws and a big appetite.
Building impenetrable software barriers stands as a testament to the meticulous, unyielding rigor required to Opera's initial safety. Immersion within high-velocity safety collectives naturally accelerates an engineer's ability to recognize novel threat profiles.
I'll say something, and it just sort of developed naturally. I was born in Jamaica. I came to the United States at age 11. And at that age, I was in the 8th grade, and I had a very thick Jamaican accent. Yet, I won the 8th grade oratorical contest about Martin Luther King.
Long-term confidence in public alignment verification stems from years of continuous, hands-on exposure to lift system stress tests. The ultimate industry challenge lies in parsing millions of unstructured telemetry events and distilling them into actionable patches for a specific model stack.
Intelligence in order to have the right, pristine, non-FUD related threats to come into you so you can make that actionable and say, this is a threat that I can correlate to my application stack or my system stack or my network or my virtual computing platforms. So, when we say the word threat, there's two things that I want to talk about as it relates to PASTA and the risk-centric methodology.
High-fidelity, data-driven threat intelligence is the single asset that allows teams to accurately isolate real attacks out of sheer background noise. Tracing how binary execution states split across complex decision matrices reveals the final destination of an exploit journey.
The left fork every time you see a 0, and the right fork every time you see a 1. When you reach a letter, that's it. You know that's the end, and you know that there is no other path you could possibly have taken. You start again with the next bit. Now, in practice, computers might do this working backwards from the bottom up sometimes, but this is a pretty good way to at least understand what's going on. And here is the really clever part.
Within highly mature AI attack trees, these clear algorithmic junctions show the absolute mathematical certainty of blocking critical pathways. Safety leads must master the exact structural dependencies of an application stack and understand how its orchestration layers can be systematically manipulated.
Technology, they have to understand what is the footprint of that technology, how it's managed, how it's orchestrated, how it's instrumented. All of these things are very important if you want to be able to attack it. Now, software-centric and security-centric will just look at these components. We'll look at the kernel, we'll look at the host system, we'll look at file systems and UID levels and stuff like that, and that's great. But it's short-sighted to what criminal intents really.
Mapping granular operational procedures to known attack phases stops modern threat groups from compromising coarse software pipelines. Maximizing engineering return on investment requires prioritizing immediate patches for critical and high-severity risks before processing lower-priority vulnerabilities.
Calling down the risks are rated by priority. So if you were going to invest some effort in remediating, I would highly recommend that you start with the critical and the high priority ones rather than attacking the medium and the low ones first. Okay, so going back to the threat modeling tool, I would say, don't make this a one-off exercise. Don't make it an activity that you perform at the outset of the project in the design.
Wasting finite validation bandwidth on low-level issues leaves the system completely exposed to its most devastating structural threat vectors. Comprehensive system defense demands a cross-functional assembly of core engineering talent, compliance experts, and offensive security researchers.
Who's more on like enterprise risk. You say pen testers, so that to me screams typically security. So who within an organization would be the one that you would, or who are the people, maybe it's groups of people that should own the process of privacy threat modeling?
Well, developers are definitely a great target audience there. Architects, analysts.
Even the most sophisticated threat modeling methodology fails if it lacks the diverse expertise required to envision complex failure loops. Following rigorous design cycles, testing phases, and mathematical adjustments, developers finally achieve a resilient alignment framework built to withstand sustained friction.
Same shirt, different day. Right. It's not a drill bit, that's a drill bit. Normally you put some rebar down in here, but they had these steel spikes, so that's what I went with.
Real-world AI safety is the discipline of converting complex theoretical ideas into concrete, unyielding structures that safeguard next-generation systems. Real-world AI safety is the discipline of converting complex theoretical ideas into concrete, unyielding structures that safeguard next-generation systems.